Okay, friends, we come to the next topic, that is symmetric matrix. So, when do we say that the given matrix is a symmetric matrix? The first thing that it has to be a square matrix, right? And a matrix is said to be symmetric matrix if A is equal to its transpose. Okay, so that is, you say that Aij is equal to Aj, right? For all the cases, then the matrix is said to be a symmetric matrix, right? So in our previous lecture we also talked about some of the examples, like a diagonal matrix, right, is always a symmetric. What do we have? Some more matrices other than the diagonal matrix which are also symmetric. So let's have few examples, like if I take A as matrix 1 2 2 3, obviously if I look at it and if I find it's a transpose, what was the first row here? 1 2, it will become first column. Second row 2 3, it will become second column. Let's cross check. What is the first row of A? 1 2. First row of A transpose 1 2. Second row of A 2 3. Second row of A transpose 2 3. So obviously A is equal to A transpose. It means that we can have other than non-diagonal matrices, we can have other than diagonal matrices also, which can be symmetric matrices, right? So it is not the condition the matrix has to be diagonal only. It could be any square matrix, but provided it is equal to its transpose. Now I'll tell you how to construct it. It's very simple. So for example, if you talk about a 3 by 3 matrix, let me consider a matrix B. What you do, you write the diagonal first, whatever it is, like I have written 1 2 3. So whatever you write here in first row, in the remaining two places of first row, same entries you write in the remaining two places of first column. And whatever you write here, same thing you write here. Now if you find B transpose, this will be equal to what? 1 minus 1 0 minus 1 2 5 0 5 3. First row was 1 minus 1 0, na? The first column 1 minus 1 0. Second row 1 2 5 minus 1 2 5. Third 0 5 3 0 5 3. Isn't B equal to B its transpose? Of course. So this is how can you actually construct a 3 by 3 symmetric matrix. ठीक है जी. You can have another example also. Let me say X is some matrix. Speak minus 1 3 2. Whatever you write in these two vacant places of first row, same entries are to be written in the two vacant places of column, like 5, you write 5. Whatever you write here, and again you're left with two vacant places. Whatever you write here, same thing you write here. So X is a symmetric matrix, right? And if you want to write for some 2 by 2 matrix, it's very simple. Write the diagonal. Whatever you write here, same thing you write here. Okay, so this is what is symmetric matrix. Next is skew symmetric. So what is a skew symmetric matrix? A matrix is said to be skew symmetric if its transpose equal to negative times the matrix, right? So what was a symmetric? If we come back to symmetric, symmetric was if the transpose of the matrix is equal to the matrix. And what is a skew symmetric? If transpose of the matrix is equals to minus times the matrix. Now one interesting thing that we studied was that a matrix has to be square matrix if its order has to remain unchanged. लेकिन जब मैं ट्रांसपोज लेता हूँ तो कौन सी एंट्रीज हैं जो नहीं हिलती हैं? डायगोनल की जो एंट्रीज होती हैं स्क्वायर मैट्रिक्स में, वो अनचेंज रहती हैं। ये बड़ा इंटरेस्टिंग सा फेज है, कभी आप 2-4 एग्जांपल्स कंसिडर करके आप देख सकते हो। ठीक है, तो अब बेटा फिर कैसे, तो लेकिन यहाँ पे तो उसका माइनस, माइनस का मतलब है कि उनके सारे साइन चेंज हो जाएंगे। तो इसका मतलब ये हो जाता है, सबसे जो इम्पोर्टेंट पॉइंट आता है कि जो डायगोनल एंट्रीज होंगी ऑफ स्क्यू सिमेट्रिक, can we have a real number which is equal to its negative? Of course. So all the diagonal entries of a skew symmetric matrix are 0. The diagonal entries of a skew symmetric matrix are to be 0. So if I consider one example, if I take a matrix A, first of all I'll write the diagonal. Now whatever I write here, I write negative of that कॉलम वाइज था ना, ए आई जे, तो आई जे की जगह जे आई लिखना है। जैसे फर्स्ट रो में जो आप लिख रहे थे, तो फर्स्ट कॉलम में जब आप लिखोगे, जब फर्स्ट रो का सेकंड एलिमेंट था तो 1 2 था, तो उसका ट्रांसपोज क्या होता है 2 1। पोजीशनिंग चेंज हो जाती है ना, सब्सक्रिप्ट होती थी ए के नीचे। नाउ इफ़ यू फाइंड ए ट्रांसपोज, दिस विल बी इक्वल टू, फर्स्ट रो जो है वो फर्स्ट कॉलम बनेगी, सेकेंड रो जो है वो सेकेंड कॉलम बनेगी। सॉरी। Now if you take minus out, the sign of all the values will change 0. It will be -2, it will be 2, and it will be 0. Isn't it equal to negative times the matrix? So hence A is a skew symmetric. Same is applicable if I want to find a matrix B of order 3 by 3 which is skew symmetric. So first of all, what will I do? I will write all the diagonal entries written. Now these are two vacant places of first row, these are two vacant places of first column, and this is of second row, this is of second column. Whatever I write here, let me say I write 2 here and I write 5 here, I'll write negative of 2 there and I write negative of 5 here. And if I write -3 here, it will be +3. If I write negative, whatever I write here, row wise, column wise, I write negative of that. If the entry written row wise is negative, then the entry column wise has to be positive. So again, if you'll check, you can check it. So you need to check, please do check. So B transpose is equal to -B. ठीक है boss? So I'm again recapitulating for you. A matrix is a symmetric matrix if its transpose is equal to this, and it is a skew symmetric if its transpose equal to negative times the matrix. Now I'm giving you some interesting concepts. ठीक है? So these are very very important key points. की पॉइंट्स भी होते हैं, इंपॉर्टेंट पॉइंट्स भी होते हैं, बट इंपॉर्टेंट की पॉइंट्स आप समझ गए ना, फ्यूजन है भैया, बहुत इंपॉर्टेंट है। तो इम्पॉर्टेंट की पॉइंट्स में सबसे पहले आप एक काम करो, टेक एनी स्क्वायर मैट्रिक्स ए। ठीक, तो जब हम सिमेट्रिक स्क्यू सिमेट्री में आ गए ना, तो मतलब स्क्वायर की बात हो रही है। ले लिया बॉस। नो टेक ए ट्रांसपोज 2/2 3/3 किसी भी ऑर्डर के ले लो आप। टेक ए प्लस ए ट्रांसपोज, टेक ए माइनस ए ट्रांसपोज। करो शाबाश, चेक करो, अभी तक हो गया होना चाहिए। यू विल कम टू नो अबाउट दैट दिस इज ऑलवेज and this is always you can check it out. A plus A transpose will always be symmetric and A minus A transpose will always be skew symmetric. Example, I'll take a 2/2 matrix. Let A is equal to, what I want to take, 2 5 minus 1 3. So what will be A transpose? 2 5 minus 1 3. Now boss, you take A plus A transpose. 2 plus 2 4, 5 minus 1 4, this is 4, this is 6, and take A minus A transpose. 2 minus 2 शून्य, 5 minus or minus plus 6 minus 1 minus 6 3 minus 3 शून्य. If you take it as x and you take it as y, and if you take x transpose, you'll come to know about this is equal to x. Now this is what you need to check. If you take y transpose, this is equal to minus y. Please check. देख लो वैसे what is the first row? 4 4 first column 4 4, second row 4 6 second column 4 6 खत्म कहानी. First row 0 6 first column negative of that, second row minus 6 0 second column negative of that. So कभी भी अगर आपको अभी मैंने एक ट्रिक सिखाया मैट्रिक्स बनाने का, सिमेट्रिक कैसे लिखोगे, स्क्यू सिमेट्रिक कैसे बनाओगे रादर, बट अगर आपको कन्फ्यूजन हो जाए, राइट, कुछ नहीं करिए, टेक एनी स्क्वायर मैट्रिक्स जो मर्जी है, टेक इट्स ट्रांसपोज